So October 2022, Unit 6. We'll start with first with the Unit 6 and then we'll discuss Unit 4 MCQs. And a student is investigating the magnetic field produced by a current carrying coil in a coil A. She made a coil A, as you can see here, by wrapping a wire around a plastic tube. Coil A is connected to an AC supply, and then a second coil B is placed in a magnetic field connected, and oscilloscope is there. So there's a change in a magnetic field of a coil A, and that change in the magnetic field, what it will do, it will induce EMF in the secondary coil. That's the electromagnetic induction. Describe one safety issue, how it should be dealt. When you're comparing, like example, as you can see, there's a AC supply is there, alternating current supply or a power supply. So there's a risk or there's a chance that a person might get an electric shock. So, and how we can overcome this, like how we should use a low voltage supply or add another resistor with a coil so that the current in the circuit will be reduced. Or you can also mention like use insulated wire for this. That will also protect us from getting an electric shock. So one mark for mentioning, like the risk is there that there's a chance that, so electricity experiment, the risk is that producing heat energy, but in this case, as you can see, a wire is there, so a person may a risk of electrocution, or a person might get an electric shock. So which can be dealt, how we can overcome this. So we can connect any resistor here so that the current will be reduced, or we use a low power supply. The next is the distance R between the two coils vary from 2 centimeter to 10 centimeter. Explain why a vernier caliper would be a better than a meter rule to measure the R. You should include calculation in your results or answer. Look, whenever we want to compare, we always try to use the term percentage uncertainty. Because what is a percentage uncertainty? The percentage uncertainty of the instrument is the uncertainty divided by value recorded into 100. That will be the percentage uncertainty. When we talk about the meter rule or a meter scale, and we can take any, like better take a smaller value, 2 centimeter, to compare the percentage uncertainties. So if I want to, we use a meter rule. Look, what is the smallest value which a meter rule or a meter scale can measure in centimeter? It can, because the value is written from 2 to 10. So smallest value or the least count of a meter rule is 0.1. And what about the uncertainty? Uncertainty of half of the least count, or the half of the smallest value which instrument can record. So what is the uncertainty here? It will be 0.05, because 0.5 divided by 2, so we'll get 0.05. So if I want the percentage uncertainty of measurement using a meter rule or a meter scale, so it will be 0.05 divided by 2 into 100. So that will give us about 2.5%. But if I use a vernier caliper can, if I want percentage in terms of like a meter rule is there, can measure about 0.1 centimeter. A vernier caliper is there 0.01 centimeter, and a micrometer is there 0.001 centimeter in centimeter scale. Like this is a meter rule, this is a vernier caliper, and this is a micrometer screw gauge. So vernier caliper, but that is the least count. What is the uncertainty? Uncertainty will be the half of the least count. So it will be 0.01 divided by 2. So what we'll get? We'll get 0.005, and 2 is the measurement. So when we multiply by 100, it will measure 0.25%. So you can mention that first thing, the least count is also called resolution. So first we'll compare the resolution. We'll say a meter rule or a meter scale is having a resolution of 0.1 centimeter, where vernier caliper is having a resolution of 0.01 centimeter. You can compare in millimeters as well. You can say this is 1 millimeter and this is 0.1 millimeter if you compare in millimeter. And what about the uncertainty? Uncertainty will be the half of the resolution. So we will work out the percentage uncertainty and we will say that it is having a smaller percentage uncertainty using a vernier caliper as compared to that of a micrometer, as we are measuring the same length, which is 2 centimeter, but with different instrument. Is it clear, this one? Comparison? The next we have when AC power supply is switched on, an EMF electromotive force was induced in coil B. The variation of EMF is shown. The Y scale is set to 100 millivolts per division. Means on Y scale, like this maximum height is equals to 100 millivolt. 100 millivolt means 100 into 10 to the power minus 3 volts for one division. Describe an accurate maximum value of E can be determined from the oscilloscope screen. So how we can determine the maximum accurate value, like maximum voltage? So what we simply do, we will count the number of, because we prefer that measuring a longer distance will reduce the uncertainty. So sometimes it gives a value stay that and stays to 0.5, like 50 plus minus 5. What will be the uncertainty? No, in that case, that number you will take as an uncertainty. Like example, what you mentioned, if it is written 50 plus minus 0.1 centimeter, okay? So if you want to take uncertainty, so you will take this value as uncertainty. This will be the uncertainty part. But for instruments, okay, for instrument, when it is mentioned, then the half of the resolution for instrument. So how we can measure? Look, the best way, because if I directly measure the height, it will be a shorter distance. So what I will do, I will measure a distance from maximum to the minimum, so that I will have a longer distance to measure. So I'll count, like example, measure a distance from maximum to minimum and divide it, count the number of the boxes. How many divisions are there? 1, 2, 3, 4, 5, 6. So how many divisions are there? So we will measure the distance from maximum to the minimum. After measuring a distance from maximum to the minimum, we'll multiply by the division, like multiply that value by 100, because each box is 100 millivolts. So measure it. How you write your answer, you will specify that measure a distance from the maximum to the minimum and then multiply that by the 100 millivolts, which is the distance for one box, and then divide the value by 2. Why divide the value by 2? Because as we know, the half of this distance is the amplitude. We want to determine amplitude. So after measuring this, we'll find how many boxes are there or how many divisions are there, and number of division multiplied by the value of each, we'll get the total length, and the total length divided by 2 we'll get 1 for 1. And for experiment, we should always repeat the experiment, and don't only say repeat, at least say repeat the experiment 4 times. Why not just measure amplitude directly? Yes, why not measure amplitude directly? Because when I measure the amplitude directly, when we measure a shorter distance, the uncertainty, look, percentage uncertainty is not affected, but uncertainty is not affected, but the percentage uncertainty is affected. Why? Because if I measure a smaller value, I will have a higher percentage uncertainty. So that is why if I get a chance to measure a longer distance, I prefer a longer distance, so the value recorded will be higher, so the percentage uncertainty will be minimum. That's why we never prefer to measure a distance directly. Even if I say, like example, if there's a box and there's an object which is hanging. So if I want to measure this distance x, so what I will do? First, I will measure this total distance from the top, and then I'll measure this distance, and then I'll subtract that. So why? Because when we measure, answer will be same, but the experimental result will have a lower percentage uncertainty. It won't affect the answer, but the technique, when measuring a longer distance or a longer length, reduces the percentage uncertainty, the chance of getting an error. Like there's a greater chance of getting an error in measuring 2 centimeter as compared to 4 centimeter. That is the idea. So answer won't change. Like example, if let's say I measure this, it is 2 centimeter. But when I measure this by a ruler, it is 4 centimeter. 4 divided by 2, I'll get 2. But this will have a lower percentage uncertainty and 2 centimeter will have a higher percentage uncertainty. So the main concept with the technique, why it is always like measuring longer than shorter, is to reduce the percentage uncertainty. The student measured the value R, a vernier caliper, and determined the corresponding maximum. The student values are shown 2, 4, 6, 8, 320, 40, 11.9, and 5. Criticize recording of this data. Student recorded this data. How you will criticize this result? First thing, you can clearly see that there is no repetition. Like student did for 2 centimeter, but he did not repeat anything for 2. Like it should be like R is there 2, then he should repeat for 2. Another EMF value should be there. 320 is there, 319 something, but there is no repetition for value for R. So no repetition, that is one thing. Another thing, inconsistent significant figure in the EMF. Here 3, 2, 3, 1. So that is the inconsistent significant figures are there. That is another thing. Then if you see the table, the EMF here, this E is representing the corresponding maximum value. But what is E here? E is representing the voltage. So inconsistent significant figure or decimal places we can mention, or the value of R. Like example, we just did for 2, but we did not repeat for 2. And there's no repetition show. So you can mention any of these points. The next, the next is the student use a transparent tube to measure the volume of a liquid as shown. The opening the tap allow the liquid to flow out at a control rate. When the tap is open, the volume of a liquid inside decreases with time according to a relation V is equals to V naught T raised to power minus B into T, where V naught is the initial volume, B is the constant, T is the time. Explain why the graph for ln V and T should be a straight line. So if I have this equation. If I take ln both sides, so this will be ln V. This is equals to ln V naught e raised to power minus BT. When two quantities are multiplied, it will be added ln, and this will be ln e raised to power minus BT. ln and e will cancel out, so this will be ln V is equals to ln V naught minus BT. If I rearrange the equation, I can say ln V, it should be, no, I'm coming, explain why the graph should be a straight line. Explain why the graph of ln V against T should be used to test this relation. I'm coming to that point only. I'm just explaining an idea about the graph. So it will be minus BT plus ln V naught. So explain why a graph of ln V and T should be used to test this relation. So because if we test this relation, as you can see, if I compare with the equation of straight line, which is y is equals to mx plus c. On y-axis, if I have ln V, on x-axis, if I have t, what will the gradient? The gradient will be negative b, means the constant, and there will be a y-intercept. Is the bt multiplied with ln V naught? No, it is not multiplied. It is the it is written V naught multiply by minus BT. And when you take ln both sides, so whenever the rule is there for ln, if it is ln A into B, it will become ln A plus ln B. So when in ln two quantities are multiplied, we write them as addition. That's why we wrote them in addition. We wrote ln V naught and we wrote ln e raised to power minus BT. ln and e will cancel out, so we are left with BT minus BT. That is the thing. Like this, it's a law of ln that when it is multiplied quantities, we write them in addition. So what we will write, explain why the graph of ln V and T should be used to test this relation. So when we will plot a graph for ln V on y-axis, when we plot a graph, we'll say by plotting a graph for ln V on y-axis and T on x-axis, our gradient will be constant, which is equals to negative B, and there will be a y-intercept that is equals to ln V naught. A student investigate the relation between V and T. Describe how student could obtain an accurate sets of value of V and T to test this relation. So we already know we want to plot a graph between ln V and T. So by using the equation y is equals to mx plus c. So first, what is V naught? V naught is a maximum. What is V naught? V naught is a maximum value of the maximum volume. So first what we do, we will fill the burette and we record it, because the things what we need, we want to test this relation and we want to even we want to plot a graph between ln V and T. Okay. So what we should do, we will fill the burette and then reset the stopwatch, and we open the tap and start the timer at the same time. And we'll record the volume in a how much specific volume is given out in a specific in a time, time for the specific volume to come out. Like let's say 10 cm cube of water or liquid, how much time it takes to come out. Then 20 cm cube, then 30 cm cube, 40 cm cube, and so on. And whenever you mention the procedure, you should always refer a precaution in the procedure. Like you should reset the stopwatch. You should look perpendicular, avoiding a parallax error, reading from the side of the marking. These are the things which you will mention. So first what we do, we fill the burette with a liquid. We start the timer and open the tap simultaneously or at the same time. And then we measure a time for a certain volume to come out. And then we repeat the experiment with different volumes and make sure that the burette is vertical, look perpendicular, avoid parallax error, reset stopwatch. These are the, and then plot a graph between ln V on y-axis and T on x-axis. And we expect this graph because it's a negative gradient and y-intercept, positive y-intercept. So it will be like this somewhat when we plot a graph. Is it clear, this one? Explain a source of uncertainty in the experiment. Can we say repeat and take? Yes, you have to say repeat and take average. That's the most important thing. Then explain source of uncertainty in this investigation. Like when you mention a source of uncertainty, you should recognize that what you're mentioning is either a systematic error or it's a random error. Okay. Like example, parallax error is there. First thing, it will be difficult to measure the volume and the time at the same time. And what is this error, random or systematic? Like what we have to do, we have to record how much volume come out in a specific time interval. I have a stopwatch, I have to read its volume. Which error is this, random or systematic? It's a random error. Why it is a random error? Because sometime the value might be more, sometime value might be less. Because if it was a systematic error, value should either all the values should be lower or either the values, all the values will be higher. Like sometime when you read, maybe the volume of the liquid is higher than what you expect, and the time, or sometime when you read, the time is longer than what you expect. So it's a random error because there is no symmetry in the difference. So when we are recording the two values simultaneously, if I say I want to measure a voltage and a current simultaneously, so that will lead to a random error. So when they ask the source of uncertainty, you should specify. So when the best way, like example, if you are recording two values simultaneously, so there will be a random error which will affect the, because when I plot a graph with these results, some results might be above the average, some results might be below the average. And that is the evidence of a random error. If it was a systematic error, then all the results will be shifted in one direction, like either below or above. Is it clear? Another thing you can mention, like when you will refill, when you was refilling, like you was filling up the burette, maybe some air trapped, air bubble is there, which error it will leads to, and you did not remove that. Which error it leads to? Good. This will be a systematic error because this is there in the system. Yeah, it is a systematic error because it will always stays the same. So this will lead to a systematic error. But if the amount of the air, this is a systematic error, but if you are refilling every time, the amount of the air trap may change. And then that case, this error will become a random error. Okay. So look, when I fill one time, let's say we were doing this experiment and we only fill the burette or the funnel once. So if I only fill the funnel once, only one time the liquid it will come out. But if I have to refill this, maybe sometime amount of air added will be more, sometime amount of air added will be less. So means the value variation will be there. If there is a variation in the value, the same thing, but it will turn out to be a random error. So as I mentioned, systematic and random errors are actually not about because of a system or because of the person. It is because if our results variation is there, we might get above the average or below the average, we'll say random. But if all the results are below average or all the results are above average, we'll say systematic. Is it clear? Same thing, the marking here, if you see this marking is not starting from the bottom. Like marking start above the bottom. So it means there is a marking, like some liquid is still coming out, but we don't know how much liquid will move out. So because of the marking, scale is not starting. Otherwise, what should be the zero levels? Like this should be zero. Then one, two, three, four. But zero is starting above. So which error is this? Systematic or a random? So this is a systematic error. So systematic error is when once the value remains same. Okay, like either shifted above or below the true value. A liquid placed inside a closed container, some of the liquid evaporate. The pressure of a vapor above the surface of a liquid increases to a maximum value. The maximum pressure is called saturated vapor pressure. Plot a graph between log P and 1 over T. So we have to complete this and use additional column. So look, there's a difference between a log and ln. Ln is called natural log and log, log is known as the log with a base 10. So No need to convert the units directly. What I will do, I will take as log in a bracket P, and the unit is kilopascal. So I will just take this 7.8, and here I need 1 over T. So I will just take a reciprocal of a T. And what is the unit of 1 over T? Because whenever you write a table is always with a column heading. So 1 over T, what is the unit of 1 over T? It will be 1 over K, or you can say K minus 1. I can write 1 over K or K minus 1. It's the same thing. So what is this value? The first value is how much? Log 7.8. So log, it is log. So don't be confused with ln and log. Ln is different. Like it is also log, but one is called natural log. Another one is a base log with a base 10. So just take 7.8, 17.0, 34, 66, and write the number here and take 1 over T here. Then determine the gradient y2 minus y. After plotting a graph, determine the gradient y2 minus y1 over x2 minus x1. Then a gradient of a graph of a log p against 1 over t is x over is equals to minus x divided by 2.3k, where k is a Boltzmann constant and x is a constant with unit joules. Determine the value of x. So if I did want to determine the value of x, this will be multiplied 2.3 times the Boltzmann constant and just take a negative sign. So I'll get the value for x in joules. Liquid boil when saturated pressure is equals to atmospheric pressure. Determine the boiling point of a liquid in degree centigrade when the atmospheric pressure is 100,000 Pascal. So for this, actually what we have to do, we have to use our graph, because if you see in the question, we want to determine the boiling point in a liquid and when atmospheric pressure is equals to so we plotted a graph between log P, which is a pressure, and 1 over T. And we work out the gradient of our graph. So what we have to do, like log P, where P is the pressure, and according to the equation which we have and the graph, as we plotted, so P is equals to 100,000. 100,000 means somewhat here. So from your graph, what you have to do, because the graph is there between log P and 1 over T. Okay. So when the pressure is 100,000 P, so what will the value for log P? I will find, like example, I will put log P is equals to 100,000 because all, the unit are kilopascal. So I will take a value of log 100. Log 100 is 2. So I will have the value of the log P. So when it is 2, I will find what is the temperature. Like what is the value of 1 over T. Then I will get the value of a 1 over T. So 1 over T is this value. Any value will be there. Let's say 400, example. Or let's say value of 1 over T is equals to 0.002. Example. So if the value of 1 over T is 0.002, I'll cross multiply. So the value of the T will be 1 divided by 0.002. What is 1 divided by 0.002? 1 divided by 0.002. That is 500. So I will write T is equals to 500, but that is Kelvin. The question I need in degree centigrade. So we know temperature in Kelvin is equals to temperature in degree centigrade at 273. So I have 500 is there. So this will be plus 273. Other side it will be minus 273. So in that case 500 minus 273. So I'll get 227. This is just an example. I'm not saying 227 is the right answer. This is just an example solution that how you can work out. So from value of the p, you will work out log p because you did not plot a graph for p and t. You plotted a graph for log p. So from value of a p, you worked out the value of a log p. From your graph, you draw a line to know what is the value of 1 over t. And from 1 over t, you find the temperature, but that is in Kelvin scale. And then you will convert this Kelvin into Celsius by subtracting 273. The next is student had two pieces of a constant ton, which is an alloy, X and Y. X and Y have a different diameter. Student measure the diameter of X several times using a micrometer. One measuring technique he should use. So whenever you are using a micrometer, we should first check for zero error to um, avoid a systematic error. And then we should change the different measure with different orientation and take an average to reduce the effect of random error. Determine the student recorded the following measurement. Determine the mean value. Mean means average. If any of the result appear to be anomalous, like not in the range, you will ignore that. And here we will add 1, 2, 3, 4, 5 and divide it by 5. So that will be the average. But how to get uncertainty of a group data? First, uncertainty is what? Uncertainty is a maximum minus minimum divided by 2. So maximum value is 0.33. Minimum value is 0.30 divided by 2. So 0.33 minus 0.3 divided by 2. That will give us the uncertainty in the measurement, which is equals to 0.015. So uncertainty in measurement is 0.015. But the problem, all the values are in two decimal places. So my uncertainty should also be in two decimal places. So what I have to do, I have to round off this to two decimal places. So keep this in mind that if the values, the minimum value, like sometime inconsistent number of decimal places are there. So you should represent in a smallest number. Like let's say if one of the value was 0.301. So I will represent in two decimal places. So I have to round off. That's why I will write as 0.02. Is it clear? That so it's very important that you see the result data which is given. If it is given to two decimal place, your uncertainty should also be in two decimal places. When a student measure a diameter of a Y, which is 0.22 plus minus 0.01 millimeter, show that the resistivity. So how to work out the resistivity? You have the formula R is equals to rho L by A. So if you need the resistivity, it will be RA divided by L. R is the resistance. You will take a ratio between voltage and current. That will give us the resistance. A is the area. L is the length of a wire, which is already given. And A is the area. So area of a wire, you will use area is equals to pi d square by 4 or pi r square by 2. A pi r square, not pi, because area pi r square is their area, or pi d square by 4. Because a radius is half of a diameter. So when I divide radius diameter by 2, d by 2 whole square will become pi by 4. So that is, you have to do show calculation. Show that the percentage uncertainty is 9%. So how I can show the percentage uncertainty 9%? So how rho is calculated? Rho is calculated by R A over L, because R is equals to rho L by A. So rho is calculated RA divided by L. R is a resistance. So what I need a percentage uncertainty in I need a percentage uncertainty in R. I need a percentage uncertainty in A, and I need a percentage uncertainty in L. And I will add all their percentage uncertainty to get the percentage uncertainty in rho. That is one method. What is another method? Another method, I will find the minimum and the maximum value. For rho, I will find the minimum value of rho and I will find the maximum value of rho. And I will do maximum minus minimum divided by 2. What will be the maximum value? Because maximum value will be when R is greater. So I will like add this because R is what? It's a ratio between voltage and current. Voltage value should be higher, current value should be lower to get the maximum value of R. And minimum value of R, when a voltage value is minimum and current value is maximum, that will be a minimum value. So this will be a max R, this will be a minimum R. And what about A? The same thing, area is pi d square by 4. So I'll find the uncertainty in the diameter uncertainty is given here, which is 0.01. But this method usually it's a longer method to work out the maximum and minimum. I prefer to work out the percentage uncertainty of each and then add. So if I want a percentage uncertainty in R, because R is calculated by voltage and current. So I'll find the percentage uncertainty in voltage and I'll find the percentage uncertainty in current and I will add them because R is calculated by a ratio between voltage and current. So just like working out the percentage uncertainty. So there will be, yes, uncertainties never subtract. Percentage, yeah, it never subtract. It's always added. Even it's multiply, divide, it's added, subtracted, uncertainty always add. So first I'll find the percentage uncertainty in R. How I'll get the percentage uncertainty in R? By adding a percentage uncertainty of V and percentage uncertainty of I. Then I need area. Look how area is calculated. Area is calculated by pi R square or pi D square by 4. So first I'll find the percentage uncertainty in D. Because area is calculated by D square, so it will be multiplied by 2. So the percentage uncertainty in area will be a percentage uncertainty in D multiplied by 2. And about the length, the percentage uncertainty in length, the length is given to us. So we'll just take like this is a length, uncertainty is given and value is given. So we'll just use this 0.1 divided by 89.4 into 100. So here, no need to divide by 2. What value is given, same you will take to calculate the percentage uncertainty. And you will have the percent. So if you are finding for rho, which is RA by L, so percentage uncertainty in R, percentage uncertainty in A, and percentage uncertainty in L, you will add all of them. You'll get the total percentage uncertainty in rho. Is it clear? The method, because the values are there, calculation. Or the other method, which is a long method, work out the minimum and the maximum. So when we square, yeah, that's right. The uncertainty, if it's a power, like example, if any cube is there, volume is 4 by 3 pi r cube. So what is the percentage uncertainty in volume? It will be 3 times the percentage uncertainty in R. Where even I'm subtracting, like example, I was calculating a quantity which is RA minus L. So what I should do, I'll add the percentage uncertainty in R, I'll add the percentage uncertainty in A, and I will add the percentage uncertainty in L. Uncertainty always add irrespective of quantities multiplied, divided, added, or subtracted. And then show that the uncertainty in R is about 2. What about root? Yeah, good question. If there was a root there, then it is 1 by 2. Like say, let's say A is equals to under root 2. So it means A is equals to D raised to power 1 by 2. So percentage uncertainty in D multiply by 1 by 2. That will be the uncertainty in A. Same thing, cube, square roots, cube roots. Like if it was a cube root, then it means it will be A multiplied by 2 because it means 2 by 3. Power 2 by 3 is there. Or power 1 by 3, sorry, cube root I said. So power 1 by 3, so it will be multiplied by 1 by 3. To get the percentage